So in today's video, here is a nice problem. It's coming from Ireland Mathematical Olympiad, but I'm not sure which year this problem is. So our goal, we are going to prove this inequality. We have this following information. We have number 2 is a raised to the n exponent to the sum as k goes from 1 to the n of k over 2 to the k, which is strictly inferior to number 4. Okay, so the method that I'm going to use, so let's set f of x, which is equals to 1 over 1 minus x. Okay, so this function, if you take a look carefully here, is going to be written on the form of the geometry series, which is going to be written on this form of x to the n as n goes from 0 to infinity. Okay, so the condition we are going to use here, but this one is valid for if you have absolute value of x is strictly inferior to number 1. Okay, so in order to have this convergence series, otherwise it's not going to be converged. Okay, I'm going to derivate this function in two different ways. I'm going to derivate this one, also I'm going to derivate this one. So starting with this one, so I get f prime of x, which equals 1 over 1 minus x quadrant squared. Okay, by applying the fractional rule for the derivative function, so get this one is 0 is multiplied by this one minus number 1 is multiplied by derivative of this one divided by 1 minus x quadrant squared. Okay, is going to give us this one. Then multiply both sides by x. I get x here, I get x here. So in the other hand, I'm going to derivate this one. So you get f prime of x, which equals the sum of n is multiplied by x to the n minus number 1 as n goes from 0 to plus infinity. Then multiplying both sides by x, I get x here and x here. So I'm going to put this x inside of this one. I get f prime of x, which equals the sum of n to the x to the n as n goes from 0 to plus infinity. Okay, x is multiplied by f prime of x equals to the sum. Also this one is going to equal to this one. Okay, so which means equals to x over x minus 1 quadrant squared, like this. Now remember here, when you get to this one here, we get the first term, and I'm going to re-index this one because n equals 0 here is automatically first term is going to give us 0. So without putting n equals 0, I'm going to put n equals 1 because the first term is automatically is 0. Okay, so now I'm going to make the combination between this one and this one. Now at this time I'm going to make the combination between the left hand side of this equation and the right hand side of this equation by replacing x with half. Okay, so doing that, I get the sum as n goes from 1 to plus infinity. N is multiplied by half to the n, so I'm replacing x with half. So I get n over 2 to the n, which equals half 1 over 2, all over 1 over 2 minus 1, which is half square, which is 1 over 4. Half over 1 over 4 is clearly going to give us number 2. So now let's link this one to this one. So if you take a look carefully here, we know number 1 is inferior to k is inferior to n, and n is strictly inferior than infinity. Okay, so this one is telling us the sum of k goes from 1 to n, okay, of k over 2 to the k is strictly inferior than the sum as n goes from 1 to plus infinity of n over 2 to the n. So why this one? Because of this inequality. Using this fact, which is in the middle, k in terms of k is automatically going to be smaller than this one. So this is finite sum, this is the converse sum. Okay, so this one is going all the way down to the infinity, this one is just goes from 1 to the n. Okay, which means always this one is strictly inferior than this one. Okay, so it's clearly we found this one, which is here, equals number 2. But remember, we have 2 to this sum. So it's clearly thus we get 2 to this sum above 1 k over 2 to the k, as k goes from 1 to n, which is strictly inferior than this one to square, which is number 4. Okay, we have proven this one. So I have done with this one. You guys, you can use the second method. Just let me know in the comment section below what you get. So by the way, don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you next video. Bye.